Good evening, everybody. My name is Moayed Akrouche, a senior student at PSUT, Princess Sumaya University for Technology. Our target today is to discuss a very specific and important example of a microwave subject, which is how to draw constant input and output gain circles using two softwares, MATLAB software and MATLAB software and Kitab software. These two softwares are designed by colleague students at PSUT as senior projects. First, I want to get you acquainted with these two softwares. The first software is the microwave MATLAB software. This software, as we can see, can calculate the transducer power gain, stability circles, constant gain circles, operating power gain circles, available power gain circles, noise figure circles, constant VSWR calculation, and constant VSWR circles as well. This process can be done by entering the values of the S parameters. As we see here, please enter the transistor S parameters, magnitude and phase for each S parameter. This process will be much understandable when we start solving our example. The second software is the Kitab software. Kitab software is a friendly user software that helps us to draw circles according to the readings we got from the microwave MATLAB software. Now let's start solving our example. Our example that we will be working on is for an amplifier with an S parameters S1 1.707 and its phase is minus 155, S12 equals to 0 and its phase is 0 also, S21 equals 5 and its phase is 180, S22 is 0.51 and its phase is minus 20. Find the input constant gain circles and the output constant gain circles for the gains of 1, 0, minus 1 dB. Now we have to import these values into the MATLAB software. As we can see here, the S parameters are imported for S11 0.707 with a phase of minus 155, S12 equals 0 with a phase of 0, S21 is 5 with a phase of 180, S22 is 0.51 with a phase of minus 20. Now as we want to draw the constant gain circles, we push the button of constant gain circles. Constant gain circles needs two inputs. The first input is the gain at source and the second input is the gain at load. The first gain we need to calculate its circles is 1 and the gain at load is also 1. Now we push the button of constant gain circles. We have the circles, the radius of the constant gain circle and the center from the origin for both load and source. Now we know we need another gain at the source and another gain at the load, which is 0. We have the readings 0.47 for the source and for the gain 0.405 and the center of course, and the third and the final one is minus 1. We have its readings also. Now it is more preferable to put these readings into a table like this table. As we said, for 1 we have a center of 0.55 from the origin and its radius is 0.38, and also the other gains we have their circles. Now we go to the Kitab software. Kitab software, of course, we have to import the Smith chart. Now we imported the Smith chart. Of course, we can in Kitab software we can zoom in and zoom out as we want. There are a lot of tools here that help us to draw accurately. Now um, we need to draw the first gain circle at gain of 1. Its center from the origin is 0.55, and the radius of the input gain circle is 0.38 at a phase of 155. Now we have to put a mark at the point at a phase of 155. 155 is here. Now we can draw a line from the origin using a ruler to the angle of 155. Here we go. Now we'll use a pencil marker, let's say, sorry, for a marker we draw the phase line. Now the phase line, now we delete the ruler, we use another tool to draw the circle, of course. Okay, to draw the circle, the first circle we said its radius is 0.55, so we draw a 0.5, 0.2, 0.4, 0.55. This is the point. Okay, now we put this on the origin. We draw this intersection between the two, between the phase line and the circle at the center. Now we have to take the radius of the input gain circle, which is 0.38. 0.38, 0.34, 0.3. Here we go. We put 0.38. Now the intersection between the phase line and the circle we draw is the origin for the input gain circle. Now we delete this, we don't need it anymore. The second circle is at a gain of 0, which is 0.47, and the radius is 0.47 also at a phase of 155. So we use this tool. Okay, take a reading of 0.47. 0.47. Sorry, this will be here. 0.4. This is 0.48. This is 0.46. This is 0.47. 0.47. The center is 0.47 from the origin. Here we go. We draw this. Okay, and it is the input, also the input constant gain circle is 0.74 radius. Here we go. Now we delete this circle, we don't need it anymore, and go for the third circle of gain -1. -1, it has a center radius, a center, sorry, of 0.4 and a radius of 0.55. So we draw center of 0.4. We point the center of 0.4. Okay. 0.4. This is 0.4. We draw this from the origin to intersect with the line of phase. Here we go. This line. Now we need a radius of 0.55. 0.55. 0.5, 2.5, 4.55. Okay, now we draw the third circle, this circle. This is the third circle. Now we delete this because we don't need it anymore, and we delete the line of phase because we don't need it either. We'll just put a label here, input constant gain circles. Input constant gain circles. Now we have to draw the output constant gain circles, which are as follows. Okay, these are the final constant gain circles. This is the output constant gain circle, this is the input constant gain circle, this is the circle of gain 1, this is the circle of gain 0, and this is the circle of gain -1, and so here the output constant gain of 1, 0, and -1. I hope I have covered the case real well to meet your interests and consider to be an added value to your knowledge. And finally, I would like to take this opportunity to express my deepest thanks and appreciation to His Excellency Abdullah Zu'bi, Professor Abdullah Zu'bi, for his endless support and consultations. Thank you.